Hi, my name is Pedro Hongitud, and this is my video about how we solve the temperature control lab situation. For having context, this experiment helps us to control systems using Arduino. The kit includes different components such as Unreal Leonardo, a temperature control shield, temperature sensors, and heaters. The system processes the temperature data received from the sensors and calculates the necessary adjustments to maintain a desired temperature. First, we collected experimental data to characterize the system's dynamic behavior. This was achieved by applying a constant input of 5.5 volts to the heater until the temperature reached stability. We decided to make a transfer function of the form g of s is equal to b divided by s plus a, where b is equal to the maximum value divided by tau, and a is equal to 1 over tau. From the graphs, we obtain the value of tau, which helps us to calculate a, and we also see that the maximum temperature was of 530 Celsius, which helps us to calculate b. With these coefficients, we get our transfer function. And for graphing, we add 20 degrees Celsius because this was the room temperature, and we compare it to the experimental values. The behavior is very similar. It has variations. These are due to the fact that a first-order system is very simple, and there always exists variations during experimental procedure. Then we propose an analytical controller with a damping factor of 0.9 and a seed time of 20 seconds. We show these parameters for creating an on-the-drum system with enough time to reduce the overshoot smoothly. Then we obtain the closed loop characteristic equation, the desired characteristic equation, and compare the coefficients. With this, we obtain the values of the coefficients of the controllers that are shown on the slide. We implemented the analytical controller with the transfer function in Simulink, and we set a set point of 40 degrees. And with this, we have this response, which the behavior is as expected. It has a small overshoot, but there are not a lot of oscillations. Then for the experimental part, we use the heuristic method. First, we analyze the original values of the system. The original behavior where there is a big overshoot and a lot of time in order to make the stationary error 0. And we also search for the impact of each PID coefficient in the system, the Kp, Ki, and Kd coefficient. After trying different values and analyzing the response of the system, we decided that the best values were Kp equals 10, Ki equals 0.035, and Kd equals 2. We keep Kp the same. It has a big value. It helps to reduce stationary state error. We decided to choose a smaller value of Ki for speeding up the process, but not so small because the Ki parameter is the one in charge to reach the stationary state error equals 0. The proportional only helps, but the integral is the responsible of this. And we also include the derivative to a moderate value of 2 for decreasing the overshoot and the settle time. And on the graph, we see that the overshoot is a lot smaller than in the real system, and the steady time is also faster. The variations are very small, they are less than 1.5 degrees. In conclusion, when designing a controller, it is very important to know the theoretic and analytical methods. This helps us to propose the best type of controller and its coefficient. But in practice, most, if not every, of all the industrial processes do not have a transfer function, and sometimes it will be impossible to measure it. Therefore, it is important to know how to use the heuristic method. We need to know how does each of the coefficients affect the response of the system. It is also important to be aware that we need to modify each of the coefficients one by one. This helps us to analyze in a more efficient way their impact and reach faster the desired result. And we also need to be aware that when moving the parameters, do not exaggerate the values because we can damage the system response. With this project, I was able to put in practice all my knowledge and reach for a solution. Even with the theoretical background, it took us a lot of time to reach the best controller. This shows the importance of knowing the control theory. If we will put this in practice, the heuristic method could have extended from hours to days. Thank you.